Hey there folks, Mr. G here with another educational video. This time we're going to be talking about adding and subtracting fractions. Now we've talked about this before in the past. Let's do a quick recap of the kind of questions that we did beforehand. All of the questions that we've covered up to this point have had the same denominator for the two things that we're either adding or subtracting. This is important because when we do adding or subtracting, if our denominators are the same, that tells us the pieces are the same size, and we can easily add them together. For our first, we have one piece shaded in out of 8. Here we have 5 pieces in shaded out of 8. So we can add the pieces together and we would get a total of 6. And 6 pieces out of 8 pieces is the same as 6 over 8. Now, we also talked a little bit about reducing fractions and equivalent fractions. And what you might notice here is that we can actually combine some of these pieces together, and we see that we've actually got 3 out of 4 pieces if we split it up in this way. So we can erase these diagonal cuts, and this would be the same as 3 out of 4 pieces colored in. They would have the same area. We say these two are equivalent fractions, but this one down here, where the numerator and the denominator are as small as possible, this is our reduced fraction. What we haven't talked about so far is what happens if our denominators don't match. Here you'll notice that our pieces aren't the same size, so we can't just add them together. Even though there's one piece here, it's a different size than all the pieces over here. So these different denominators mean different sized pieces, but we want them to be the same. So what we can do is take 1 over 4 and see if we can find an equivalent fraction so that it has the same area, but our denominator is now 8. We've solved questions like this before. If this is being multiplied by 2, then we can do the same thing to the top, and we would get an equivalent fraction of 2 over 8. Now our problem becomes something that we can definitely solve. 2 over 8 plus 5 over 8. And notice, we have the same area for the first one. It's just that our one piece has been split into 2 pieces, and now all of our pieces are the same size. And we can see we've got a total of 5 plus 2, that gives us 7 out of 8 pieces. And that would be our answer. Now this works the same when we have subtraction problems too. If we have a question like 5 over 12 minus 1 over 3, you'll notice the denominators aren't the same. But we can change this fraction right here so that it has a denominator of 12. So if we want 1 over 3 to have a denominator of 12, we multiply by 4 on the bottom, tells us that we need to multiply by 4 on the top. So we can change this problem to be 5 over 12 minus 4 over 12. These are equivalent fractions. Once we get it here, we know that we can subtract these numerators. 5 pieces minus 4 pieces gives us 1 piece, and our piece sizes stay the same, which tells us our denominator stays the same. What about this question here? We've got different denominators again, but if we try and find an equivalent fraction for 1 over 6 with a denominator of 8, there isn't a nice whole number that we can multiply by. So this isn't going to work. If that ever happens, what this tells us is that we need to change both denominators. In particular, we need to find a common denominator, which is basically one that they can share. So if they have a shared denominator, that's the same as a common denominator. There are 2 different ways that we can find a common denominator. The easiest or simplest way is to just multiply both our denominators together. So if we do 8 times 6, we get 48. 48 can be the common denominator. So now we need to convert both fractions so that they have a denominator of 48. For our first one, in this case, we're multiplying by 6, so we need to do the same on the top and multiply by 6. For our second denominator, we do the same thing. Here we need to multiply by 8 on the top and the bottom. And now we have our question. We can update it from here where they don't have a shared denominator to one where they do. 42 minus 8, that gives us 34 over 48. Now we can reduce our fraction and get our final answer of 17 over 24. This is a perfectly good way of solving this problem, but what you'll notice sometimes is this can get really big. And if we have a really big common denominator, that means all of the numbers are going to get really big, and sometimes that can make the problem a lot harder than it needs to be. and you might end up doing a lot of reducing at the end, it can just take a lot more time. So while it's simple to find the common denominator, you can end up spending a lot more time converting both of these to really big numbers and then having to reduce it at the end. This method will always work though, so there's an advantage there, but it's not always the best choice. The other way you can find a common denominator is to look at multiples of 1 until it's divisible by the other. This is called finding the least common denominator. I can show you how this works. So we start off by looking at 8 and 6. So first, 8 can't be divided by 6, so 8's not our common denominator. Next multiple of 8 is 16. Can 16 be divided by 6? Nope. So that's not going to work as well. What's the next multiple of 8? It's 24. Can we divide that by 6? Yeah, we can. So 24 would be our least common denominator. So now we're going to turn 7 over 8 into something over 24. In this case, we're multiplying by 3, and we'd get 21 over 24. For our second one, we're multiplying the top and bottom by 4 to get 4 over 24. So our question of 7 over 8 minus 1 over 6 turns into 21 over 24 minus 4 over 24 when we make these with common denominators. 21 minus 4 gives us 17, and we keep our denominator the same. Notice we didn't have to do any reducing compared to our other example. But we spent a little bit more time finding our least common denominator. But regardless of which method you use, if you do it correctly, you'll get the right answer. So there isn't a wrong way of doing it as long as you follow the steps. All right, 2 questions here. Grab a piece of paper, try them out for yourself, and then we'll go over the answers in just a second. All done? All right, let's try these out. So first one here, let's see if we can turn this into a fraction with a common denominator of 18. Notice we can multiply 3 by 6, which means we can do the same thing on the top here and get 12. So we can rewrite this problem as 23 over 18 minus 12 over 18. 23 minus 12 gives us 11. We keep our denominator the same. We can't reduce it, so that's our final answer. For our second one here, this is a little bit trickier because there's no number we can multiply 12 by to get 16. That's also a whole number. So we can't use this trick here, so we need to find a common denominator. Now we could do 12 times 16 as our common denominator, but that's going to be a pretty big number. So instead, I'm going to try and use that multiples method. So starting with 16, can we divide it by 12? Nope. The next multiple of 16 is 32, divided by 12. Nope. Next multiple is 48. Can we divide it by 12? Yes, we can. So this will work. So now we want to find fractions with a denominator of 48. To go from 16 to 48, we're going to multiply by 3, so we're also going to multiply this top by 3. So here the top would be 17 times 3. Over here, 12 to 48 is multiplying by 4, so we would need to do 3 times 4. We can add the tops together, we leave the bottoms the same. And then from here, we can reduce our fraction by dividing the top and bottom by 3, and get our final answer of 21 over 16. That's the end of the video here. Stick around for the second part where we're going to be talking about some word problems with adding and subtracting fractions. See you then.